In this video, we're going to discuss about the properties of Z transform. The first property is linearity property, where two signals x1n and x2n and their coefficients multiplied by two coefficients a and b, and the sum of these two signals in time domain is equal to their equivalent sum of their Z transforms and multiplied by these coefficients a and b. So ax1n plus bx2n will be equal to ax1z plus bx2z. So the ROC or region of convergence for the output of this combined signal will be the intersection of their individual ROCs R1 and R2. So here we can take an example to find the Z transform of a signal which is combination of two subsignals like this: 3 to the power n un plus 4 to the power n un. So we know that the Z transform of a to the power n un form is given by z minus a. So this a is constant, so it is subtracted in the denominator from z minus a, and due to the positive value of a here, the ROC becomes mod z greater than a. So in this case also you can see that these values are plus 3 and plus 4. So we can write their Z transform like z by z minus 3 and z by z minus 4, and each ROC will be z mod z greater than 3 and each ROC will be mod z greater than 4. So if we plot these ROCs, so if this point is 3, then mod z greater than 3 indicates this region and mod z greater than 4 indicates this region. So the intersection of these two regions will be the region which is specified by mod z greater than 4. That is, the ROC of this combined Z transform XZ will be mod z greater than 4. Next, if we take this example, so here the value of this constant minus a is here minus 3, and this n index is for the negative values of n, so it is represented the left hand side up from 0. So the transform of this is similar like un to the power n un. So here also you can write z by z minus a, so a is equal to 3, so z by z minus 3, but this ROC will be the reverse of the positive value of a, so that is mod z greater than 3 becomes mod z less than 3 due to this negative index of n, while this is positive and this ROC will be mod z greater than this constant a 4, and Z transform is given by z minus 4. So this constant is subtracted here. So if you find the common regions between these two ROCs, so you can see that mod z greater than 3 less than 3 is the left hand side of 3, and mod z greater than 4 is the right hand side of 4. So the common space in these two ROC will be null because it doesn't exist. That's why the XZ doesn't exist, because there is no common section between these two Z transforms. So it is not possible to find the Z transform for this signal. So next property is time shifting property. So if xn is given by xz, so if you perform time shifting operation from n, so n naught is a constant. So if we subtract this n naught constant from time below n, then this frequency domain representation or xz z transform output will be multiplied by z to the power minus of n naught, that constant. So if we see here, for the given signal xn, by this signal indicates the coefficients of that discrete time signal. So if we consider this signal starts at -1, so this means that n is equal to 0 is at this position. So if n naught is equal to 0, we have to put this z to the power minus n naught here. So -1 into z to the power 0 plus 3 into z to the power minus n naught means minus 1. So if we are starting from 0 here, then it is 1 2 3 4. So if you have to put the value of n here, 1 2 3 4 basically, and here we can see that this n naught minus n naught we are writing, that's why a negative symbol is there in front of these values. So these coefficients are the given value of the signal, and we are multiplying with this z to the power minus n naught for z transform. Okay, so if we put the z to the power g equal to 1, we will get minus 1. Then here 3 by z, 6 by z square, minus 4 by z cube, plus 5 by z to the power minus z to the power plus 4. So if you see that here, the z is in the denominator and it should not be equal to 0, otherwise it will become infinity, since the 1 by z is there. So we cannot take z equal to 0 value. That means ROC will be all the real values of z except 0. That is entire z plane except mod z equal to 0. Next we take this example. Here the center point or n is equal to 0 is indicating at this point 3. So at n is equal to 0, its coefficient is 3, and these values are in the left hand side. So this means this will be minus 1, minus 2, minus 3, minus 4. So if you put z to the power minus n naught, then minus into n naught value, if it is negative, then it will be minus into minus positive. So we are getting the positive power of z here. So if we start from here, 3 into z to the power 0 means 3 into 1, so 3. Next z into z to the power minus n naught means minus of minus 1, that means plus 1, so z to the power plus 1. Similarly we are getting other values here. The coefficients are multiplied by z to the power minus n naught. So n naught value will be the indexes here. So it is minus 1, minus 2, minus 3, minus 4. Okay. So here you can see that to if z transform exists, then this should be less than infinity. That's why z cannot be equal to infinity, as here you can see that if z is equal to infinity, this term will become infinity, z will become infinity. So that's why ROC will be the entire z plane except mod z equal to infinity. Similarly this example also you can do. So here if it is n is equal to 0, here negative indexes, and this is right index positive indexes. So if we see that here minus n naught becomes plus, z to the power powers becomes positive, and here it is negative. So here also to find the ROC, we can see that z cannot be infinity or z cannot be 0. That's why z minus 0 and infinity. So entire z plane except this element. So next property of z transform is time reversal property or time folding property. So we know that n indicates the discrete time for the signal xn, and its transform is xz. So if we put minus n, it becomes the time reversal signal of xn, and its z transform will be given by x of 1 by z. So if you put minus symbol here, then the xz can be obtained by putting 1 by z in place of z. So here to get the ROC of x of minus n, we can replace z by 1 by z or z inverse in the ROC of xz. Okay. So here if you see that e of minus n, so a to the power n un becomes z by z minus s. So here if you take a is equal to 1, then e to the power n, so the transform is z by z minus 1, and mod z greater than 1 is the ROC. So if you put minus n here, so we can, due to time reversal property, we can replace z by 1 by z like this, and here also in the ROC 1 by z will use. So we can write u of minus n z transform is equal to 1 by 1 minus z By solving this we can get this, and here h1 by z is greater than 1, so z will be less than equal to 1. Similarly, if we take this un is equal to z by z minus 1 here, then if we shift the signal in time domain n minus 1, then we have to multiply by z to the power minus 1. So if we multiply here z to the power minus 1, we will get 1 by z minus 1. Then if we fold this signal now, u of minus n minus 1, then we, due to folding operation, we have to replace z by 1 by z here also and in the ROC also. So here if we put 1 by z minus 1 in the ROC, it becomes 1 by z greater than 1 or z less than 1, mod z less than 1. So solving this you will get z by z minus 1 and modulus of z less than 1 is the ROC. So now you can see that if the signal xn is a constant 1, then we can write 1 as un plus u of minus n minus 1. So we can combine these two signals to indicate a constant 1 value. So here the ROC of this un is mod z greater than 1, and the ROC of un minus 1 minus n minus 1 is mod z less than 1. So since these two ROCs are indicating two different areas which are not in common, so the intersection becomes phi. So and thus the ROC of or you can say that z transform is equal for xn is equal to 1 is not possible.